you've heard about the idea of the limit of a function f of x as x approaches a set number a being equal to another number that we'll be calling L. So what exactly does this mean? Just to point out to you that from now on, everything that you'll be doing in calculus, in fact, calculus is based on relationships on the Cartesian plane. So everything that we'll be looking at in calculus will be done on a Cartesian plane. So without further to say, let's move on to our drawing of the Cartesian plane to explain the concept of a limit. So let's draw our Cartesian plane, also known as our xy plane. And we have an x value that we'll be calling a. Now, every x value is searching for a corresponding y value or f of x value to be mapped to. How it finds this f of x value is by, it's like it looks in both directions for a graph. And upon finding a graph, what it does is that it selects the corresponding f of x value, which in this case we'll be calling f of a, and that is a value that it is matched with. Now, a is not the only x value that is searching for a corresponding y value or f of x value. Every x value is searching for a corresponding f of x value. And so let's say that we have x values. We have an x value here. Let's call this one s. And let's get closer to a. Let's say that there's another value, r. And let's get even closer to a. There's another one, q. Now, since we have these values here, from s to q to r, we are saying that you have a set of values that are getting closer and closer to a. Now, let's choose values that are less than a. Let's choose values such as, let's say, m. And then let's get even closer, n, and even closer at o. So here, we have values, we have x values that are approaching this value, a, from both directions, from this direction and this direction. Now, the question that we would like to answer is, since these x values are approaching a set, we have a set of x values that are approaching a fixed x value, a, can we say that the corresponding f of x values for these other x values are approaching a set number 2? So look at f of o, f at n, and f of m. As m, n, and o, as those get closer to a, are their corresponding y values or f of x values getting closer to f of a? And look at q, r, and s. As q, r, and s get closer to a, are their corresponding f of x values, particularly f of q, f of r, and f of s, are they getting closer to f of a? Yes, they are. And so that is what the question, that is the question that the idea of limits seeks to answer. That is, as I pick values that are arbitrarily close to a set x value, values that are approaching a set x value, do their corresponding f of x values approach a set number 2? In other words, let's put it this way. We're saying that if we make the expression, if we claim that the limit of f of x as x approaches a is equal to L, that is implying to us that as values of x get closer and closer to a, in other words, as they approach a, then their corresponding f of x values are approaching a set number L. And so that is how we come up with the idea of limits.